This is Io, a moon where extreme gravity is so violent it literally lifts the solid rock ground 100 meters into the sky. Think about this. Deep in the freezing void of space, Jupiter's massive gravitational pull is constantly stretching this entire world into an egg shape, turning the underground into a churning engine of endless magma. Out here in the distant reaches of the solar system, objects are expected to be quiet. Most of the large moons orbiting the giant planets are dead, frozen orbs composed of heavily cratered ice and rock. Io breaks that pattern completely. It is incredibly dense, composed of solid rock and metal. It is completely dehydrated, making it the driest known body in the solar system, even drier than Mercury. The reason for this extreme environment starts with its location. Io is caught roughly 350,000 kilometers above Jupiter's clouds. That puts it right on the edge, far enough out to avoid being instantly torn apart, but close enough to be permanently locked in the grip of the planet's staggering gravitational pull. But Jupiter isn't the only force at play. Further out, the other three large Galilean moons exert their own collective tug. This opposing force prevents a perfectly circular orbit, dragging its path into a stretched oval. Because of this, the moon's distance to Jupiter changes violently. As it swings close, the solid rock physically bulges outward, and as it pulls away, the surface snaps back. That relentless cycle of stretching and squeezing acts like an enormous pump. The friction generated deep underground produces intense heat, operating as a perpetual geological engine. All of that internal pressure requires an outlet. On Earth, sliding tectonic plates can force rock upward to relieve stress, but Io has no tectonic plates. Instead, the solid crust simply absorbs the strain until it fractures. Once a weak point snaps, molten rock blasts directly through the newly formed cracks, spraying straight up from the ground. These volcanic eruptions carry thick plumes of highly concentrated sulfur gas that blast hundreds of kilometers into the dark sky above. That massive volume of ejected material doesn't float away. Gravity pulls it back down, allowing the chemicals to settle across the moon and permanently coat the landscape. From orbit, the expansive yellow regions are pure sulfur that has crystallized in the extreme cold, falling back like snow. The stark white and blue patches are sulfur dioxide, frozen solid within the coldest, darkest shadow regions of the moon. The vibrant green streaks are sulfur monoxide, formed high in the atmosphere through violent chemical reactions with Jupiter's intense radiation. And the deep red marks highlight areas where the sulfur is actively baking above the fresh, hot sites of recent eruptions. This intense array of color is a direct record of the moon's geology. The surface is continuously repainting itself, providing a real-time, constantly updating map of its own violent destruction. With up to 400 active volcanoes erupting, it would be logical to assume that Io is floating on top of a single, continuous global ocean of magma. But probes measuring the local gravity fields have found that the internal pull is highly uneven. The magma is actually trapped in hundreds of isolated pockets, pooling underground only in the specific areas that experience the most extreme tidal flexing. When a localized engine erupts, the rock above loses structural support. The crust collapses into the void, creating huge, churning lava lakes. As millions of tons of crust plunge downward into the molten pocket, the pressure forces the geology to react. Like a seesaw, the sinking lake mechanically forces adjacent solid rock to shoot upward. The visual result of this displacement is a feature known as a steeple mountain. These spiky shards of rock stab directly into the sky, towering up to 18 kilometers high. On Earth, tectonic pressures create long, continuous mountain chains. Because Io's structures are driven by isolated sinkholes, they appear entirely alone. There are no dense ranges, just solitary lone wolf peaks rising out of nowhere. Because of how they form, these peaks don't push upward over millions of years of gradual movement. Instead, driven by those massive lava sinkholes, the displaced solid rock bursts out of the ground violently and suddenly. The entire landscape is locked in a relentless rhythm. Sections of the ground are continuously collapsing into deep lakes of fire, while right next to them, massive spikes of rock are violently thrust outward into space. Almost everything we know about these towering mountains and isolated lava lakes comes from a narrow window of recent observation. Our detailed view is entirely thanks to close flybys completed by NASA's Juno spacecraft. But Juno is running out of fuel, and despite gathering the data to prove Io operates as a perpetual motion machine, these images could be the last we ever see of this world. Space agencies are pivoting their focus. The modern era of planetary exploration is moving away from purely geological anomalies and shifting heavily toward a single pursuit: the hunt for extraterrestrial biology. The next major probe bound for the Jupiter system is the European Space Agency's JUICE mission. When it arrives in 2031, its instruments will bypass Io entirely to map the icy surfaces and hidden liquid oceans of Jupiter's other moons. NASA is following the same path with the Europa Clipper. Launching later this decade, its primary objective is to scan the watery depths of Europa specifically for chemical signatures that could support alien life. Io is simply too hostile for those missions. Its highly radioactive environment and continuous volcanic resurfacing guarantee